Hey folks, good morning. It's a pleasure to be here with you all. I'm Luciano Martins. I'm a Brazilian. I'm an AI developer advocate at Google DeepMind, and I'm here with my friend Shrestha.
Thank you, Luciano. Hi, everyone. I'm Shrestha Basu Mallick. I'm the product lead for the Gemini Developer API, and looks like I should have brought an Indian contingent here. Thank you.
Yay! Okay, so the idea of this conversation is we want to share with you some of the new things you have available to develop your solutions using Gemini models and the Gemini API. How many developers you have here? Amazing. Okay, so we can start talking about the Gemini models universe. We started Gemini by the end of 2023, and since then we have done a lot of work together between many different Google DeepMind teams, and by now we are very proud of the point we got in and all the stuff we launched during I/O. Just doing a quick recap, one of the key differentials of the Gemini is that it is multimodal from scratch. Like, since when we started developing the model, it always handled and understood multimodal data. It means that you can work with Gemini with any format of information you want, from text, image, video, audio, code, anything. Right, Shrestha?
That's correct. And just a quick overview of what are all the types of models and what are all the families of models we have available. So what we're going to do today is Luciano and I have split this talk into two parts. So the first part of the talk, we'll be talking about the models, and then the second part of the talk, we'll be talking about the API, what are the capabilities and functionalities available through the API, and as part of that, we have a section where we do a deep dive on agentic capabilities in the API.
Yeah, thanks for the ad.
Yeah. So starting with, what are the families of models we have available? So the most performant and powerful model that we have is the Gemini 2.5 Pro. It's in preview right now. A few weeks ago, we released an updated version of 2.5 Pro, and it's suitable for highly complex tasks that require a lot of deep reasoning. I mean, and coding has been, of course, a standout use case of that. We also have 2.5 Flash, which this Google I/O we released a new preview version just yesterday for 2.5 Flash, and for 2.5 Flash is our model size that has probably one of the best price-performance ratios in the market today.
That's right.
We also have 2.0 Flash Lite. So this is a small, fast, cheap model that you can use for high-volume tasks like summarization. And then, Luciano, do you want to talk about the nano and the embedding models?
Yeah, absolutely. We heard a lot of feedbacks from you folks, and many of you are developing mobile applications or applications that must run on devices. So then you have also available what we call the Gemini Nano, which is a smaller version of the Gemini, which is able to run locally on devices like on Android devices if you are developing with the Android Studio using the AI core. And also, many of you are trying to create applications that do some kind of semantic ranking or to organize information in large scale. So you have also one model that we call the Gemini embedding, which the key objective of this model is to let you ingest text, and then the model delivers you high-quality multidimensional embeddings. But how those models are behaving when we think about the key standard benchmarks?
Yeah, we'll go to the benchmarks in a second, but the message that I want everyone to take away from this slide is whether it's a super complex task or whether it's on-device processing, you now have a Gemini model that you can use for it, and it's pretty powerful and it's pretty price effective.
Yeah, maybe it is also worth mentioning, Shrestha, that some folks here may be developing with Gemini since it was released.
Yeah.
So using the AI Studio, using the Gemini API, the older versions of Gemini, like 2.0, 1.5, are still available, but we really encourage everybody to start experimenting with the newer ones with better capabilities and better performance, right?
That's correct. So 2.0 Flash continues to be one of our most widely used models, just again because of how good it is for the price it's at. And we have a lot of people who are still using it. And then we also have some people on the 1.5 models, but we're encouraging people now. We're 2 generations ahead, so start using the 2.5 series of models and give us feedback.
Nice. So please tell us a little bit about the benchmarks, Shrestha.
Yeah, next slide. Yeah, so we're not going to spend a lot of time on the benchmarks, but the 2 key points that I'd like to hit here is, number one is one way in which we measure how good these models are is by putting them on LM Arena, which is where developers and builders like yourself test out all these models and give it an ELO rating. And we're, of course, very proud that right now you have 3 Gemini models in the top 10 in the LM Arena.
Including the top one.
Including, how did I forget that? We are number 1, guys, and we're very proud of it. Thank you. One of the use cases that has been really emerging in the last couple of months is, of course, app creation and vibe coding and going from 0 to 1. The best leaderboard right now for that is the Web Dev Arena, and we, again, are number 1 with 2.5 Pro on Web Dev Arena. So if you're trying to build 0 to 1 or few-shot apps, Gemini 2.5 Pro is a great model for that. But in addition to user preferences, we also like to measure how well our models are doing based on rigorous academic benchmarks. And so I'm not going to go into a lot of details on these slides. These are available in blog posts. Reach out to me and Luciano if you want to know how exactly these models are doing. But the TLDR here is whether it's in highly complex domain-specific questions, whether it's in coding, whether it's in multimodal understanding. The Gemini 2.5 Pro is leading on a lot of these academic benchmarks as well. Finally, performance is one side of the coin. The other side of the coin is, of course, price. This is a chart from Swix that's been very popular on Twitter for the last few years, on X, I'm sorry, for the last few months. But this really shows that even for price performance, the Gemini 2.5 models are really at the frontier. Luciano?
Yeah, and I think it is worth mentioning, Shrestha, especially for those of you who watched the Sundar's keynote yesterday and also the developers' keynotes. We, inside the DeepMind, we are doing this huge effort of trying to cover the different aspects of experiences you may have. So we will talk a lot about Gemini here, but also we have the model family that we are calling Gen Media, where you are able to generate high-quality images, high-quality videos. You also have, and there is a colleague from our team, Paul Ruiz, who is delivering a talk this afternoon related to the Gemini robotics, the Gemini family of models related to people applying robotics, developing robotic solution with applied AI. And also, just after this session, we have another one with Omar and Gus Martins to talk about Gemma 3, which is our open, the open models family from Google DeepMind, also developed with all the technologies we use to develop Gemini.
And some really good benchmark performance in Gemma 3 as well, as Omar and Gus will tell you.
Okay, so still talking about the different experiences you may have. We heard a lot of feedbacks from you folks around the world, and one of most asked features we always heard were related to having, letting Gemini to create high-quality audio. So yesterday, we launched what we are calling the Gemini TTS model, where you can, from text, generate high-quality audio. But the coolest thing about the TTS is that you are not just creating audio. You have abilities to customize emotions on the audio. You may have multiple voices. You can create the audios with different languages, like Brazilian Portuguese. And you can even create multi-speaker interactions. So if, for example, you want to deliver an experience where your users will be thoughts about something on a podcast-like format, like the one you have on the Notebook LM that people love. Who here is using Notebook LM for anything? Amazing.
Ah.
So you can have like something like the AI overviews developed and delivered by the Gemini TTS model using the TTS, right, Shrestha?
That's correct.
And I think it is not the only thing related to audio. We brought that to the live interactions as well, right?
That's right. So the TTS models, like Luciano said, are available via our chat endpoint. And then on our live API, yesterday we also rolled out the native audio output models. So this is now Google's first release of an audio-to-audio architecture. And there are two variants of this model that you have access through the Gemini Live API, which is our real-time API. So you have the native audio dialogue model, which is, the real benefit of the native audio output models are that the voices that come out of it are much more natural and much more compelling. The native audio-to-audio architecture has better contextual understanding of what humans say to the AI. It can seamlessly transition between different languages, so maybe from Brazilian Portuguese to Bengali if you want to switch in the same language, in the same sentence. And it's available on our Gemini real-time API. We also have a version of this model available, again on the real-time API, with thinking enabled. So for more complex use cases, so one use case that comes to mind is, let's say you're building a gaming agent to play a strategy game. And you want that agent to be able to think, but also to talk to you with relatively low latency. We have a thinking version of the native audio model that's also now available from the live API. So please try it out and give us feedback.
Perfect. So how people can start using those models, Shrestha?
Through the API, of course. But before we go there, there are two other things that we should mention. It's hot off the news. You've probably all heard about it. We've also enabled an advanced reasoning mode called Deep Think. And the idea behind Deep Think is that you can, the model 2.5 Pro can think through various possible answers to a problem before giving you the best answer. So that's is available in trusted testers, but will be rolled out more widely soon. And then we also have Gemini Diffusion, which is, the first time we are testing a diffusion architecture as opposed to an autoregressive architecture. And these models are faster than the fastest model out today, and for almost similar the performance. So try out both when you have access to both Gemini Diffusion and Deep Think.
Perfect.
All right. So the Gemini API.
So yeah, if you start thinking, especially after the keynotes yesterday, there are many surfaces where you can interact with the Gemini models. So you have the Gemini app, you have Gemini available on Google Cloud as the code assist, the assistant on the cloud assist inside the console. You have a Gemini on Workspace. So when you are talking about developer experiences, we have the one specific Gemini API with similar experiences as you have on the no-code UI that we call AI Studio, where you can start experimenting and developing your solutions using the Gemini models, right?
That's right.
So basically, the Gemini API is a very low barrier entry for having Gemini programmatic experiences. You have access to all public models there, from the Gemmedia ones, Gemma, all the Gemini models variants. You have a very generous free of charge tier where you can start experimenting like just after this session without concerns about credit cards, costs, billing, anything like that. We are developing, we keep developing more SDKs for this API. So for now, you have available one SDK for Python, JavaScript, Go, and Java. We launched Java during I/O, right, Shrestha? And also, you have the ability to use the API on other developer the developer tools you may be using. Like, for example, if you use Firebase Studio, the API is available there. If you are a Google Colab user, you have ways to interact with the Gemini models as well. So the key idea is to make it easier for you. No matter where you are having your development experience, we are trying to bring Gemini API closer to you.
That's correct. And I think this is also a good place to make a plug for Google AI Studio, which of course everyone knows about and loves. It is the place where a lot of our developers first test out the capabilities of the API before committing to building applications at scale with the API. And Google AI Studio now has code generation also available. So this is a quick high-level overview of all the components that are available through the Gemini API. It's pretty standard. You send in your prompt. You get a response back from the model. If there's a tool call needed, we do support a set of first-party Google tools as well as function calling. So in terms of the first-party Google tools that we support, we, of course, support Google Search as a tool. The best search engine out there is now available as a tool for the model to call when it needs to. Now, in addition to the information that you get out of search, if you want to retrieve more in-depth content from web pages for applications such as you're building your own version of a research agent. So you pull some information from search, you pull a set of URLs, but if you want to extract a little more in-depth content, we just released a new tool at I/O called URL Context. And then, of course, you can take all that information, and if you want to create beautiful charts out of it or run some analysis, we make code execution available as a tool to you via the API as well. Then, of course, you have function calling. And as part of all the improvements that we've released at Google I/O, we've also put a lot of effort into making sure our structured outputs functionality, which lets you get outputs in JSON schema, is much more robust and comprehensive. So again, try it out and give us feedback. And then finally, we do have a set of safety and copyright filters. These are configurable by developers. The idea is, in order you have the tools you need to make the applications you build safer. And you have control about how, for most of the filters, you have control about where you want to set that threshold.
Perfect. So as a TLDR, if we could explain on a tweet how that works, with the Gemini API and using the SDK, you can work with all information you need. Doesn't matter on which format it is, if you have like spreadsheets, docs, PDF files, videos, audio, live interactions via voice and video, right, Shrestha? If you need to give specific instructions to the model, you have the ability to bring system instructions to the model follow on every interaction you have during your application usage. And you have as results or as outputs the ability to have generated text or generated images or audio or video, or even keep chaining with more API calls using function calling.
That's correct.
That was a huge tweet.
That was a huge tweet. Maybe threaded tweet. All right, so let's talk about some key Gemini API features. Like, we don't have enough time in this talk to go through everything, but Luciano and I thought we would hit some of the highlights that we really want people to know more about and use. So one of the areas of feedback that we used to get a lot is you can, of course, upload files to the Gemini API. You can also, if you're less than 20 megabytes, you can also pass some of these media information in line. But now you can also, and we've had this feature out for a few weeks, you can also pass a YouTube link. And the Gemini API can analyze that information. When you pass media files like videos, depending on how much you want to fit into the context window, you have now a choice between 3 resolution settings. At the lowest setting, you can process up to 6 hours of video. But then you also have more high resolution settings that you can use. We support dynamic frame rate per second in the Gemini API. You can read that, more about that in our documentation, or come talk to me and Luciano. We support video clipping, that's a new feature, and we support image segmentation. One other point I want to make on multimodal understanding is even in the days of 1.5 and 2.0, the Gemini models were some of the best models out there for multimodal understanding. You know, the example I like to give here is I was in Costa Rica and my guide showed me, this is night, and my guide showed me, oh, there's a glass frog somewhere there on a branch. I took a photo, but I did not see the glass frog in real life or in the photo. But I passed it to Gemini, and Gemini not only saw the frog, it identified the species correctly. So that's how good multimodal understanding is on the Gemini. Please try it out. We also support long context. Along with long context is we have some of the largest context windows out there. So like the equivalent of, depending on whether you're using a model with 1 million context or 2 million context, like you can read the equivalent of like 8 novels, have the model read it, or entire code bases. But what can sometimes happen with long context is that your input token pricing goes up. But for that, we now have context caching. We have been supporting what we call explicit context caching for a while. Explicit context caching is when you tell the API, cache this context and reuse it for the next few turns. And you were going to get a 75% discount on the pricing. But now what we support is implicit context caching. So if we feel that you have a context that is getting repeatedly used, we will automatically cache that for you and pass the price savings to you. So again, hopefully this is a huge price benefit to our developers. And then we, of course, provide you with transparency to see how many tokens you're using.
That's amazing.
Yeah. You want to talk a little bit about text generation?
Yeah, I think one of the greatest things that we are building step by step with the Gemini models and the Gemini API is you may have different experiences, as Shrestha explained, with videos and clipping specific time offsets or changing the frames per second. And then the first like out-of-the-box output of Gemini when we launched it in December 23 was text generation. Yeah. So we keep having this as one of the choices you have. You can have an experience where Gemini will just create text, and by text it may be like anything. It may be one structured JSON output, or it may be some coding in Python, C, or any language of your preference. But then we keep increasing the semantic understanding capabilities of the models. So we are not just uploading one PDF file with a lot of text and some charts and some conclusions. You are also counting on the Gemini ability to understand how the information on those documents or on those spreadsheets connect to each other, especially if you have a more complex situation where you are sending multiple PDF files or PDF files with spreadsheets and videos and everything. Without a huge heavy lift from your side, you can count on Gemini to understand what's the message, what's the information, what's the reasoning behind all that information, and do the math or do the understanding for you. Right, Shrestha?
That's correct. I just want to give a special call out to 2 features here, which again, developers have been asking us for. One is you can get bounding boxes through the API. And secondly, in addition to bounding boxes, you have what's called image segmentation, which is you get the bounding box information for an object in the image. You get a classification of what that image might be. So that's sent to you as metadata. And then you get this masked segmentation of that specific area and that object as well.
Nice.
We also support streaming. And you can set system instructions on top of whatever system instructions we already have in place.
Yeah, and I think that's the same for the JMedia models, right, Shrestha? So now you have basically 3 main doors to use JMedia models. You have the Imagine tree, the Google DeepMind model with the best high-quality image generated.
Yeah.
You have one variant of Gemini that we call Gemini Image Out that lets you also generate images, but with two key differences from Imagen 3. First, you can have interleaved outputs, including text and images together, like having one explanation, one step-by-step guide to do some action, including visuals. And also, you can edit images, right, Shrestha? So you can have one first version of the image generated. You want to change the shirt color or the background or add glasses to the character on the image. You can keep chatting with the model, asking to modify the image, and you keep enhancing and optimizing your result, right, Shrestha?
That's correct. And through VO, you all saw the release of VO 3. That'll probably come soon to the API. But with VO2, we support text to video and image to video. This is, again, from a recent blog post that our researchers put out about a week ago. You can see that 2.5 Pro also, as I mentioned earlier, leads on key video understanding benchmarks like MMMU. So that's, that's also something that we're very proud of. We've been pushing the boundaries on. OK, so now let's talk about the live API. So a lot of our features, as I mentioned, are available through the chat API, but we also provide the Gemini Live API, which is our real-time, low-latency API for use cases that require more of these interactive, real-time kind of experiences. There are two architectures now available through this live API. There is the cascaded architecture, which has native audio input, but the output is done using text-to-speech. And we were using the same text-to-speech models that was used by NotebookLM. A lot of people prefer this architecture because it's more reliable. We've had it out since December, and we're aiming to bring the latest 2.5 Flash model to this architecture. We also, starting I/O, now have the audio-to-audio architecture that I mentioned, where you have native audio input as well as native audio output. And this, of course, native audio output, as I already mentioned, gives you much more natural-sounding voices and the ability, you don't now have to specify a language. You can seamlessly switch between languages and flow in and out. We support tool chaining in the live API. We have supported this since December. So all of the tools that I mentioned, search, code execution, URL context, function calling, you can layer these tools in the same prompt and get much more compelling results. Get data from search, do some analysis, get the output. We have voice activity detection. Of course, we need it in the live API. What we now provide for you, though, is the ability to configure the thresholds. How much of time do you want after the end of speech to decide that the user's speech has ended? Like, that's one of 4 thresholds that you can now set with the live API. You can also disable our voice activity detection model and bring your own. Session management, we have a lot of parameters out there. So in its most basic state, the live API currently supports about 20 minutes of audio and about a few minutes of video. But we now have various techniques for you to increase your session length, including sliding window, the ability to change resolution on what video is passed, the ability to decide do you want audio to be streamed only when, do you want video to be streamed only when audio is being spoken, or even when audio is not being spoken, and other parameters that you can use through the live API. Ephemeral tokens are coming soon, but that's one way to do authorization into the live API. And finally, with the native audio output, specifically the audio-to-audio architecture, we are also releasing a couple of modes for you to try out. One of them is proactive audio. What this feature does today is it lets the AI decide when to respond to you and when whatever the human is saying is irrelevant. So imagine if I'm having a conversation with the AI and Luciano comes to me and says something unrelated. The AI will know not to respond to that audio output. So the AI proactively decides not to respond. So we are calling it proactive audio because we aim to bring much more proactivity to this feature. And then effective dialogue lets you pick up on the user's tone and sentiment and lets the AI respond appropriately. As I mentioned, you also have thinking available with the live API. All right, time for agents.
Excellent. So how many of you are trying to experiment solving your computational problems using agents or multi-agent solutions? Yay, everybody
All
loves
the
agents.
Brazilian contingent.
Okay, so with that in mind, we always try to develop the new tools and the new capabilities of the model, thinking how you folks can use them in your projects to make agents better and more trustful. Right, Shrestha?
That's correct.
So if you start thinking about how a regular agents architecture work, what do you have there, Shrestha? So basically, we have three main blocks.
Yes.
We normally see one orchestration layer, one models layer, and one tools layer, right?
Yeah, may I build upon that? I think, as we've been mentioning, with the 2.5 series models, these models are predominantly trained to be really good at planning and reasoning, which when you think about it is a key part of what makes an agent work. So the model layer is where a lot of the planning and reasoning happens. And then, of course, there's the tools layer. We've already talked a lot about, we have a set of first-party hosted tools from Google Search, code execution, and URL context, as well as a few other tools. Some of you may have heard Sundar mention the computer use tool that's coming. So we're going to make it available through the API. We've already rolled it out into trusted testers, but that's going to be publicly available soon. And then we have a couple of other tools on the way as well.
All right.
And then there's the orchestration layer, as you were saying, Luciano.
Yeah, absolutely. So basically, when you are creating an agent, you want to give like key directions to these agents. So basically, how it's going to behave, what's the profile of this agent, what's the goal of it. It's going to help with researching, with coding, with learning, any specific area you are trying to address actions for your users. You need to count with some memory for these agents, so you can keep like the previous user's interactions with the model, or you can try to extend this agent memory using any mechanism like RAG, or adding PDFs, or using the long context. And also, you must count on the model to do the key reasoning part of this agent. So how to bring all those stuff together, how to give the best answer to the users, and when and how to use each of the tools that are available to this agent.
That's correct.
So yeah, so basically, if you put all that together, we are looking for applications that we are calling like agentic applications or multi-agent applications, where we want some autonomous integration with our tools. We want those agents to take actions to help our users. We count on the models like the Gemini 2.5 Pro, the best one on reasoning capabilities, to reason and plan all the actions to be given to this user, from like helping with shopping to generate new code for a new application. This model must be able to be continuously learning, so if you want to append more pieces of information, fresher information, use like tools like the Google Search grounding, right, Shrestha, to bring up-to-date information from Google Search. This model must be able to support that. And at last but not least, we count on multi-agent collaboration. So we must be able to not create huge monolithic agents, but also to keep connecting to other specialized agents to bring a better experience, right?
That's right. You've probably heard us talk about all of these components 50 times already in this talk. So I'm going to go through the slide really quickly. But one thing we wanted to emphasize is when we started thinking about how to enable agentic capabilities through our API, we made a conscious decision on first focusing on providing high-quality primitives And once we had made some progress along that, that's when we have now started to do things like release MCP through our SDK, and you'll see some more higher abstractions rolling out in the next couple of months. But in terms of agentic primitives, again, we have the 2.5 series models, which are thinking first models. You now have Deep Think, which is an advanced thinking mode on top of 2.5 Pro. And with Flash today and Pro soon, you have the ability to set budgets. So you can tell the model when to think and how much to think. And that lets you both control cost, latency, and whatever is the amount of thinking that's suitable for your application. In terms of API, depending on what agent you're building, you may want to use different versions of the API. So if you're building a research agent, maybe you want to use the chat API. If you're building a gaming agent, maybe you want to use the real-time API or a customer support agent. Of course, you can build research agents also on the real-time API, but in general, you now have these two APIs. And then we've talked about tools a lot. So all I'll say is give us feedback in terms of what are some of the other tools that you would see Google make available through the Gemini API.
Yeah, so as you just said, the Gemini 2.5 Pro 2.5 models are thinking capable, so they can do more advanced and more complex reasoning.
Yeah.
And maybe we could highlight that now specifically for the 2.5 Flash, we have the ability of using what we just mentioned, the thinking budget, where you can calibrate how deep and how much the model will do reasoning cycles. And also, for both models, we can have access to what we are calling thought summaries.
Yes.
So basically, you are not only counting on the model ability to reason, but also you can see on your response which key steps or which key reasoning thoughts the model had to get to our conclusion. So basically, that's a pretty basic Gemini API code using the Python SDK. For those of you who never used the SDK before, it's pretty straightforward. So 3 key blocks. You need to import the SDK, you instantiate the client, and then you interact with the model you want. Here, we are interacting with the Gemini 2.5 Flash. You send your prompts, and then you have one specific bit called thinking config, where on this code, you are asking the API to include the thought summaries on your response, and that's the include thoughts equals true, and also the amount of tokens you want to use during the reasoning process. On your response, you're going to have part of the response will be the thought summaries. So it's separated from the final answer by intention. If you want to keep those on your backend, on your data warehouse, your BI environment, you are free to do that. And also, you have a second part, which is the final model answer that may be like, for example, the part that goes to the end user, right, Shrestha? That's correct. So here we added like 2 quick GIFs showing how the thought summaries work. You have on the left GIFs the AI Studio experience, and on the right the Google Colab experience. And pretty much we ask it the same question, and you can see how you can interact with the thoughts on both environments, right, Shrestha? Okay, so what about the enhanced tooling we have now, Shrestha? I think in the interest of time, we can skip this slide because we've talked about tools a lot. The one point I do want to make is I mentioned when I was talking about the live API that one of the things we started doing in December itself is we allowed you to chain tools, so use multiple tools together in the live API. We're now rolling that out to the chat API as well, starting from search and code execution together. But you'll see the ability to do more combinations of tools in the chat API as well. Amazing. So basically, that's what you just said. That's a similar experience with the SDK. Now you have 2 tools included on your interaction. You have, in this case, the code execution tool and the Google search tool. And then on your answer, you can see, also on separated structures, the code execution results, including the Python code used by the code execution, and also the output of this execution. The Google search grounding results, including the Google search, real search that was performed, and the results of this. And final answer from the model, right?
URL context, as we said, this is a new tool that we are rolling out. It's one of the tools that powers deep research if you've used Google's research agent through the Gemini app. And the idea is, given a set of URLs, we allow you to extract more in-depth content, of course, in a way that's approved by and respectful to our publisher ecosystem, but you can get more content out. And this is really helpful for research and analysis type of use cases. You can use this tool by itself, or you can use this in tandem with the search tool.
Yeah, and again, a quick code snippet. You add the tool called URL context, and you can send directly on the prompt without further efforts all the links, up to 20 links you want to consider on the model processing, on the model execution, and you have all the reasoning, all the semantic extraction performed by the model really fast.
I feel like some people are still taking pictures, but if you all missed taking an image of a slide, all of this information is available in our documentation.
Absolutely.
And Luciano and I are also here to answer questions. Function calling, I think we've had, of course, function calling is bread and butter for all kinds of agentic applications. The Gemini API has supported single function calling, parallel function calling, and compositional function calling for a while. Compositional meaning where you can put a whole logic around if A happens, then call function 1. If B happens, then call function 2. As part of I/O, we are also releasing asynchronous function calling through the live API. So imagine some tasks like you start having a conversation with the AI agent, but in the background, you ask it to crank out on some other task. And that task may not be a real-time task, but it may be something that's relevant to the conversation, like maybe analyzing a lot of context about the user to provide some answer. You can now turn on an asynchronous function. The function will do its thing in the background, and then when ready, it will notify you with the results.
Amazing. And maybe one of the greatest news for the Gemini API SDK during I/O is that we heard you, many of you gave this feedback for us, and we added to the Gemini API SDK support for MCP. So now you don't need to have like separated and siloed codes with MCP clients, MCP servers, and then your Gemini API interactions. You can have it all together using the same code base of the Gemini API SDK.
Very exciting.
Yeah, and thank you. And still talking about like those interactions, we know that we have many choices of agents frameworks. You may have heard about the Google ADK, the Agent Development Kit, launched during the Google Cloud Next a few weeks ago. We may have heard about the agent-to-agent protocol as well. You have other choices like LangChain, LangGraph, everything, and we keep open, collaborating with all those internal and external open source efforts to bring the best experience for you all.
That's correct, and especially thanks to folks like Philip Schmidt and Patrick here on our developer relations team. We have been working on building closer relationships, closer interactions, better code samples with some of the leading agent frameworks like LangChain, Crew, and so that is also some of the areas where you'll see the Gemini API show up.
Amazing. So if you folks are concerned about a lot of the amounts of stuff we've just shared today, that's a huge dump of things. Maybe the best suggestion or the best guidance we could give you is first, as Shrestha mentioned, we have the Google DeepMind DevRel team distributed across the globe. We have people in Latin America, in Europe, in Asia. We have a huge presence here in the US. So please count on us, connect with us online, on-site events like this. And think on like those top 6 actions when you are creating your agentic experience, from having clear objectives on your mind try to laser focus on the problem you need to solve. Do a lot of interactions on your development. Do live coding if you need to, do vibe coding if you need, if you are working with something you are not that familiar. Count with the Gemini 2.5 models to help you with your coding experience. And always focus on your user experience. That's the best key for success you may have with your tools, right, Shrestha?
The OG rule of product.
Absolutely. So yeah, and that's it. I hope you enjoyed that. Start building now. We brought you here. Thank you. We give you some links here, so some of you may get the reference. But basically, the first link is the AI Studio, the UI and no-code experience where you can experiment all the Gemini models, features really fast without writing a single line of code. The second link is the Gemini API docs, where you may find all the things we shared here and a way more of the other features and possibilities with the models. And the last one is the Gemini Cookbook, a GitHub repository that our team curates and keep updating with a lot of sample experience for you. Thank you so much, Shrestha. Thank you much,
you all for coming out to hear us.
Hi, everyone. Good morning. I'm very happy to be here. Welcome to my very dear to my heart session, What's New in the Gemmaverse. It's something we really work very hard to bring to you. So one question that we get a lot is, what is Gemma, right? What's this new thing? We have Gemini, but what's Gemma? Let me give you one step back and try to explain to you why we do all that we do. In Google DeepMind, we, of course, try to push AI research as much as possible. But the important thing about that is, and we really want to solve intelligence, right? How can we make systems be intelligent? This is a very hard task. It's not something that you can just pull it off. We need everyone to collaborate. And that's why we think that's very important to make our research available to everyone, to make it available to developers, to other researchers, to regular users, just so that it evolves with everyone and everyone can collaborate. We've been publishing great work for a while. I guess you've seen AlphaFold, AlphaZero, AlphaStar, all of this AlphaEvolve, all of them. I think that's not the real name. But the idea is we push this technology because we want to make sure that everyone benefits from it. And when we wanted to create an open model, the idea was, first, AI for everyone, make sure that everyone have access to it. And that's why being open matters. That's why we want everyone to be able to try the model, change the model, make it their version, make their own. That's very important to us. And another very important thing that we have in mind is making these as responsible as possible. We know that these models, they bring a lot of power, but we also would like to have the same responsible perspective on it so that we go beyond benefiting people, protecting people from the harms that they could cause. So that's the idea of all these models. Whenever we train them, we keep responsibility as one of the main things for all of them, right? And that's how we got to Gemma. Gemma is our open family of open models. They're based on Gemini technology, and they're available for you in many flavors and sizes. I'm going to go into some details soon. We launched them last year, and we've just completed like a one-year anniversary. It was a beautiful journey. Last year, we presented them here. So it's been, if you know me, you've seen me talk about them for a while now. When we released Gemma 1, we had two sizes, which was a 2B and a 7B. But what does that mean? So when we say a model is basically a very long math equation, right? Very long. And for each small a times x, b times x, for each one of these a, b, c, we would say that's kind of a parameter. When we say 2B, we say that there are 2 billion parameters. So it's like a gigantic math equation with 2 billion parameters. That's like a layman version of what it is, right? Don't tell this to a researcher. But the idea is that a 2B is like a very large model, right? But it's kind of small compared to other models. And we released also a 7B. And people really like them. And since then, Gemma has been downloaded over 150 million times. I guess we're close to 160 since we created this slide. So things are moving super fast. We're very happy with the results so far. Since our launch, we released many variants ourselves, right? We created multiple versions. So for example, there's a bunch of names here. Let me go a little bit, for example, PalyGemma. PalyGemma was a model we released last year at Google I/O, right here, which is the first Gemma model that has vision. You could give an image and ask a question, and it was the best VLM, Visual Language Model, that so far. It was great. That's why we did a PalyGemma 2 in the end of the year. So we kept pushing. We also had other variants like Shield Gemma, which I'll talk a little bit more later, which the idea is a safety classifier. So you can do, I'll explain the details later, but the idea is to make your AI systems even more responsible as a whole. Aside from the regular variants, we also publish more core models, as we say. When we say core models, we release Gemma 1, and then we release Gemma 2, and then we released Gemma 3 beginning of this year, and yesterday we released Gemma 3N that I'm going to talk a little bit more in a little bit. And more than tools, we also release some tools to go around our models. For example, we have Gemma Scope and Gemma.cpp. Gemma Scope is some tooling for you to see inside of all the layers of the models and help you interpret why some results, right? You give a prompt, why do you have this result? This, as I said, these models are quite large. So understanding how you go from Luna loves strawberries to some emojis, it might be very hard to explain that. So Gemma Scope helps with that. Gemma CPP is our implementation of our Gemma models completely on C++. And you would say, oh, yeah, why would you do that? When we do that, it enables you to run these models on CPU only and super fast. So if you have a computer that doesn't have a strong GPU, which I guess the majority of people have that, you can still use these models only on CPU with a very good performance. And the fun thing is, like in March, we released Gemma 3, our most capable model so far. We had 4 sizes, 1B, 4, 12, and 27B, and they were all state-of-the-art. I'm going to go into details in a little bit. But the idea was, we've learned a lot with the community. We've received a lot of feedback. We've learned from our own, from researchers, from everyone, and want to make the best models possible. So what came with Gemma 3? First of all, community really liked for the models to see beyond just text. So of course, Gemma 3 is multimodal. There's 4, 12, and 27B. They can all receive an image, and they can do more than that. They can do a conversation. So you can ask a question about an image, and you can continue with a multi-turn conversation. You can add more images. You can do all of that. That's part of the base model already. More than that, one thing for Gemma was always, it was English only, but we got feedback from the community that for 2 things. The model could generate text in other languages, right? And we were very surprised, which was they had very high quality in other languages, but we always said it's English only. So what we did is, okay, let's make it really multilingual. So Gemma 3 now supports over 140 languages. And it's quite good in many of them in the benchmarks, in all the ones that we could run at least. So this is a very strong capability. I guess, I don't know, let me tell you a little secret here. I don't know if you notice, English is not my first language. Yeah, can you believe that? So for me, having a model that can really help in multiple languages and multiple cultures, it's really, really important, dear to my heart. As you can see, there's a lot of users of Gemma that are not from US, and they don't speak English as the main language. Maybe I'm part of that 64% over there. So the idea of having a model that embraces multiple languages and cultures is part of what we want to make in terms of accessibility, right? That want everyone to be part of it. And the other thing that we improved for Gemma 3 is we made the context window longer. What is a context window? When you write a prompt to these models, this text you're sending, let's say that's the context window. So the larger the context window of a model, the more information you can give per prompt, and the longer you can do a conversation, right? The other important thing is when you add an image, for example, you give an image and ask, like, describe this image. All of that eats up, let's say like that, your context window. So the longer or the larger context window you have, the more your model can process. And you can also have longer conversations. I guess 128, you can put like a book. You can put multiple, I guess 500 images. You can do a lot of stuff. You can put all these, you can put a video and ask questions about the video. So it's very, very powerful. And before we were at 8K, so the community complained, we improved that. As you can see here. So we were from 8K to the 1B has 32K context window, and the 4, it's 12 there. It shouldn't be 14. 27B have 128K context window, which is great. The 1B has a shorter context window because it's aimed for smaller devices. One other aspect of context window is, of course, there's no magic, right? If you give a more prompt, it eats up memory. So if you're using a 1B model, we expect you to be using a weaker machine, so you will have less memory anyway, right? Otherwise, you go for the 4B, which is stronger. Here's a fun graph of how the models keep the quality while we increase the context window. And we say that the context window for our models is 128K. You can see over there, right? But the fun, if you look at the green one, the green is the 27B, right? The lowest line over there. If you try 512K, it will still do good results. But of course, we benchmark until 128. That's what we say it's good. But it can go a little bit further. Let's see some examples of how the model works. Here, I'm giving an image, and I'm asking, how much is this ticket? And the answer to the right, you can see there that, first of all, the model can understand what's this and extract the price, which is in Czech koruna, which is, I never use that currency, sorry if I'm saying wrong. But the model can see and understand and parse that. And then the fun thing is we can follow up with a question, and how long is this ticket valid? Can you, of course, you just read what's written there, but did you see that in the ticket before? Could you answer that answer? Could you answer that yourself? Can we go back one slide, please? Can you go back one slide, please? Yes. Can you see there how long is this ticket? Even for me, when I was looking for the first time, I was like, where does this information come from? So on top left, the information is there, right? And the model knows that, and that's what it says there. So it lasts for 24 hours. So the model has all these, and you can keep the conversation, right? Another cool thing that the model can do is, of course, every feature, that capability I told you, they all work together. It's not like one or the others. They all work together. So on this example, can you translate this picture? I'm using the vision capability, the text understanding, of course, and the multilingual, because that sign has at least 4 or 5 languages, right? And it translates from all of them without like any extra prompts. It just knows all of them, extract information, and give you context of where this sign is, right? And this example, when I saw for the first time, I was like, well, this is very strong. I didn't expect that to happen, to work so well. And one important aspect for us is, as I said, the feedback you give. You give us a lot of feedback. Sometimes you're harsh, but I like the feedback anyway. Thank you very much. And the idea is, why does that matter? It's because we want you all to succeed with us. So Gemma can really help you on your applications, on your systems, whatever it is. So your feedback is very important. So my colleague here that will present after me asked, what else? What do you want from Gemma? We asked openly. We got a lot of replies. Of course, people said, we want larger context window. We fixed that. We want smaller models. Remember, I told you that first model was 2 and 7, and then we released Gemma 2 was 2, 9, 27. People wanted smaller models. We did the 1B model, and all models are now quantized. We released the quantized versions that are smaller models, but they still keep the quality. So the 27B, it's like, I'll be very honest, we have the 27B, is great, super powerful, blah, blah. But the 12B, which is like the middle son, let's say like that, it's amazing. It's like, the quality is so strong, and you don't need too much hardware to run that. That's amazing. Can we have more modalities? Yes, we added vision, so you can do image and video. We also added more languages, as I told you, 140 languages. Community love that. And we need system prompts. Okay, we'll get there. Although, to be honest, people want system prompts. It's like, system prompt is before the conversation, you tell the model how it should behave and put some ground rules. We don't have a system prompt role, but if you add what you want to the first message, the model will follow that. The Gemma models are very strong at following instructions. So whatever you say, do X, Y, and Z, it will do X, Y, and Z. So if you say, talk like a pirate, the most basic system prompt, it will talk like a pirate during the conversation, right? So we don't have a role for system prompt, but you can add to the first message and it will work. you can add at any moment during a conversation, and it will, from there, continue with your instructions. And people love also the personality of Gemma. Personality is how the model replies, right? When you ask a question, the way it answers. People like it's warm, it has a strong personality, it's approachable, and that's why we have a LM Marine score so high. And as you can see here, I guess those numbers are updated. Those are the LM scores for our three larger models, the 27, 12, and 4B. And this, and what's so great about this? First of all, this is from LM Arena. This is a benchmark that people go and blind vote on prompts, right? So you have a prompt, it gives you two answers, and you say which one you prefer. So this is from kind of the voice of the people, let's say like that, right? There are, of course, criticism, but this is one of the best benchmarks we have. It's people's choice. And on this benchmark, you can see the 27B is one of the top ones, and it's an open, remember, open model. Anyone can download and use right now. We are one of the best open models, period. And the other thing is, our 27B needs one GPU to run, while the other open models that are large, that are better, let's say like that, they need like 30 GPUs, 10 GPUs. Do you have 10 GPUs to run now? Do you have access? So that's one of the important things. You can see the small dots over there. And you can see the 12B, the middle kid. The 12B is really close. It's super strong. And you can see the 4B over there. I'm not going to say who is after that, doesn't matter. But the idea is that if our 4B is really, really strong for 4B, 4 billion, right? Can run basically most of your devices. I'm not saying phones. And here we see our capabilities in terms of in specific languages. So if you look for Gemma over there, it's right there at the bottom. You can see we were top in French, top in Spanish, second in Japanese, third in German. It's great all around in multiple languages. Again, open model, right? This is very, very strong. And as of yesterday, we released Gemma 3N, our newest model that can run on as little as 2 gigabytes of RAM. Gemma 3N has a lot of development. I'm very impressed by what the research behind it, and it's optimized for on device, so the architecture is focused on making on device or on small devices it to run faster. It's the same model, it's the base model that will be also used for Gemini Nano, which comes embedded in many, many Android devices already. So it's the same architecture, so we're sharing that as open models now. We expanded the capabilities. Gemma 3 has vision, text, and video, right? Gemma 3N, we added audio understanding. So now you can talk directly to the model. And this is very, very interesting. This is very new. Oh, let me run because I have my friend. And we're releasing two sizes, 4B and 2B. Today, you can test these models already on Google AI Studio. Let me show you this video.
Can you tell me about this replica?
Certainly. This is a replica of a Virgin Galactic Spaceship 1, a suborbital spacecraft. It's a model of the vehicle used for testing and demonstration flights.
Can you please save these to my notes?
Absolutely. Creating a note.
This is running completely local. There's zero internet, and it was just saved to Google Keep. It runs
What can I
completely on
add to
device.
the system to make it faster?
Interesting question. Adding caching layers can significantly improve speed. Consider implementing a CDN or caching proxy to store frequently accessed content.
Write a super short poem that highlights her skills.
Amazing Zoe, so bright. Counting to 100, what a sight.
What is the total square footage of the largest room?
The largest room is the living room. Its dimensions are 18 feet by 12 feet. The area is 18 times 12, which is 216 square feet.
Can you guess which famous figure is this?
This is a cartoon drawing of Einstein. The wavy hair, the mustache, and the mischievous grin are all telltale signs.
Nice. Thank you. Thank you. This is all running completely on device. Of course, in an internal app we have, it's like not available to everyone to test. But this is the capability that Gemma 3N offers. And all of it on device, you ask, can the model speak? No, that's using text-to-speech from the Android phone, the native one that everyone has. But that's cool, but how do you build using Gemma? How do you take these models and make your own? For that, I would like to call my friend Omar to continue and explain to you all the details. Thank you.
Thank you. Thank you, Gus. So I'm very excited to be here to talk about Gemma, the fantastic open source ecosystem, and how to build products with the Gemma models. As Gus mentioned, we have been talking with the community. We have been talking with startups, with researchers, enterprises, companies, developers. And as part of that, we want to make Gemma as easy as possible to use. We want to make Gemma very accessible to the developer ecosystem. So the easiest way to get started is with AI Studio. So if you go to AI Studio at ai.dev, at the right, you can pick among many different models. And within those, of course, you can try out Gemma. So you can test your prompts. You can see if the Gemma models work for your own use case. Right? There are different model sizes. And depending on what you want to do, different model sizes may work. And just a few weeks ago, we released also image input in AI Studio. So you can try out an image. So for example, here, we uploaded an image of a croissant, right? And you can ask, describe the image, and then the model will give you a description of the image input. So let's say that you go to AI Studio, you try out Gemma, the model works well for you, and you want to deploy this in production. So in the same interface, there is a new button when you have Gemma selected that says deploy in Google Cloud Run. So you have a button that says export the code. And it will give you a code snippet in Python or in TypeScript or in REST or in AppScript, whichever is your favorite language, which you can use to run and build your own applications using Gemma. This is using the Google APIs. The code is actually very simple. You just first instantiate a client. You specify the token, the Gemini API token. Then you pass the text, the content. You can also pass images. And then on the right side, you will create the text, right? You will generate the text. So you pass the name of the model. So in this case, Gemma 3, the 27 billion parameter version. You pass the text, and you pass the content configuration. So a new feature in AI Studio is that when you have a Gemma model selected, there is this new button called Deploy in Cloud Run that I was mentioning before that allows you to create an endpoint that will automatically scale. So if you wanted to scale to 100 GPUs, or if you wanted to scale down to 0 when there is no usage, Google Cloud Run will take care of all of it. And the very nice thing of this is that you don't need to change the code. There are just two lines of code, if you saw the details, that you need to change. You need to change the URL, and you need to change the token. So you just change 2 lines of code, but the rest is exactly the same code as before. But that's not the only way to use Gemma. Gemma is designed to be easily integrated into your favorite open source tools. So of course, there is Google AI Studio, but we also support Gemma in Keras, or in VLLM, or in JAX, or Ollama, or Hugging Face Transformers, PyTorch, MediaPipe. So there are many different open source tools that you have probably used. And the idea is to make Gemma as easy as possible to use there, to enable developers to run the models locally, because that's the cool thing of open models. You don't need an API necessarily, right? You can run these models in your own laptops, in your own phones. And we'll talk a bit more about that. But this is a good opportunity for me to talk a bit about Kaggle. Kaggle is the platform where AI builders, learners, developers, researchers participate in AI challenges. There are over 24 million people participating here. And here you can discover models, you can share knowledge. And within those, of course, you can find the Gemma models. You can find the Gemma models, read the model card, which is like the documentation of a model. You can download the checkpoints. OK, let's say that now you want to go and download and run Gemma in your computer. Who here knows Ollama? OK, many of you. That's great. So Ollama is a tool that is designed to very easily, very seamlessly run Gemma models, open models locally, right, in your own computer. So with a simple command, Ollama run Gemma 3, it will download and create a local API or a local chat interface that you can use to experiment with the Gemma models. The nice thing of Ollama is that it's very well integrated into many open source tools. So if you use Llama Index, for example, you can consume Ollama. You can use Ollama to consume different open models. Or same for LangChain. So if you have used LangChain, you can combine LangChain and Ollama to very easily use open models such as Gemma 3. Ollama, by the way, is also integrated in Google Cloud Run, so you can very easily deploy a model with Ollama through Google Cloud Run. Ollama is just one of many different open tools to run open models. So another one very popular is Keras. Keras provides high-level APIs that are designed for very quickly prototyping and building with models, right? You can build models, you can experiment, you can train very easily. It gives you very nice, simple abstractions that let you try out the Gemma capabilities and build products with it. So here you can see the code. First, we load the Gemma 4 billion parameter model with a specific precision. So I'll talk a bit more about precisions in a couple of minutes, but in this case, we are using bfloat 16. The second part is passing the actual text to the model. And you may see there that there are some weird words, start of turn, end of turn. What's that? So when you go and you train a model, you use a specific format. So when you train a model with conversations, you use a specific format. And the idea is that when you actually want to run a model that was trained, so if you download Gemma 3, for example, you want to use the same prompt structure, the same text structure as what was used to train the model. So some libraries, such as Ollama, take care of doing all of this for you, while other libraries, such as Keras, give you more fine-grained control on the prompts and allow you to control how things work. Just a couple of months ago, with the Gemma 3 launch, we also announced a Gemma Python library. It's powered by JAX. It also gives you high-level abstractions that let you run the Gemma models. And it has 3 key components. It has the tokenizer, it has the model configuration, let's say, and it has the actual model parameters. And this JAX library gives you this sampler class that lets you combine the model, the parameters, and the tokenizer into a single class. And then when you do sampler.sample rows as a red, it will keep generating the text. Finally, if you know Hugging Face, they have this library called transformers, which give you a very high level also a pipeline as a class that lets you say, I want to do text generation with a Gemma 3 12 billion parameter model. And just like that, you can specify, OK, the user is saying, who are you? Answer in parrot speak. You pass that to the model, and the model will keep generating. So as you can see, Gemma is deeply integrated into many of your favorite open source tools. And we are talking with all of these developers to make it as easy as possible to run them. Now, these models are running in your computer. And as Gus was mentioning, we have models that go from 1 billion parameters to 27 billion parameters. And you may be wondering, can I run this model in my own computer? So each parameter is stored with a number, right? A specific precision. So previously I mentioned bfloat 16. That means that there are 16 bits for every single parameter. So kind of rough napkin math, so this is just an approximation, is that for every single billion parameters, you need 2 gigabytes of VRAM. So you need a GPU of 2 gigabytes. So the 27 billion parameter model, it's 54 gigabytes. And probably most of you don't have that at home. So now you may be wondering, can I actually use these models? So there is a family of techniques called quantization. Quantization reduces the precision of the parameters. So you can go down to 8 bits per parameter, 4 bits, even 2 bits. And as we reduce the precision, the quality begins to degrade a bit. So the models may become worse than the bfloat 16. So you may be wondering, OK, can I reduce the precision while maintaining the same quality? And this is a good moment just to show with int4. So if we quantize the model, now the 27 billion parameter just needs 14 gigabytes of VRAM, which is quite good, actually. I personally really like the 12 billion parameter model. It's a very nice size, just like 6.6 gigabytes of VRAM to load the model, which is a size for most normal computer GPUs. So it's a very friendly size. A few weeks ago, we released a QAT, quantization-aware training checkpoints of Gemma. QAT is a technique that allows you to make the model more robust to quantization. It's a very small additional training stage. And what that means is that once you quantize the model down to int4, the model will preserve the same quality as the larger model. So it will be a bit worse, but you don't have so much quality degradation. So now with the Gemma 3 models, you can also try out the QAT checkpoints that are specifically aimed to make it very easy to run the models locally. So I've been talking a lot about how to run and how to load the Gemma models. Now I would love to talk a bit more about the Gemmaverse, which is composed of tens of thousands of variants, tools, libraries built by you, the developer ecosystem, and also researchers. It's a vibrant ecosystem with huge adoption. And just to understand it a bit more, it's good to talk about pre-training and post-training. So in LLMs, there are usually two main stages. In the pre-training, you usually train a model from scratch. That needs lots of data, lots of compute. And the outcome of that stage is that it's a model that will predict the next token. It's not the one that you would put in a chat interface or in a product. There's also the post-training stage. So if you have heard about RLHF, QLoRa, PEFT, fine-tuning, that's post-training. And the idea is to make the model better conversational, right? So I'll talk a bit more about that in a minute. But for Gemma, we released both the pre-train and the post-train checkpoints. The pre-train checkpoints work as a foundation for the community to build their own models with their favorite fine-tuning tools. And the post-train checkpoint is a generalist conversational model. But there are many cases in which you will want to fine-tune your own models, right? So when may you want to do that? If you want to add new capabilities, if you want to make the model better for Spanish, for example, so for your own languages, if you want to make the model better for your own domain, so if you have your own company data and you want the model to learn about your company data, you can fine-tune. And these are models that you own, that you can host in your own computers, in your own servers. So you already saw the LM-Arena score. So what you see here is actually the chat model. It's the post-train checkpoint, which is a generalist conversational model. But again, you can fine-tune Gemma for your own use cases. So if you have your own internal leaderboards for your own use cases, this is where fine-tuning will come in. And there are many different fine-tuning tools. So again, I mentioned already Keras and Hugging Face. There is Onslaught and Axolotl, which are two other very popular open source libraries to fine-tune models. I will not dive too much into the code for the sake of time. But with transformers, for example, there is TRL, which is a high-level wrapper that allows you to very easily, just with a SFT trainer, do the training of a model. Or Onslaught. Onslaught is a wrapper around Hugging Face transformers that makes it very, very, very easy to run to fine-tune models with very limited compute. So in a free Google Colab, in a Kaggle instance, for example, you can use Onslaught to train models. And this is extremely quickly, without losing any quality. So it's a very strong technique to do fine-tuning. And there are over 70,000 Gemma-based models built by the community. The top three are multilingual examples. So we have seen people training Gemma for Korean conversations. We have seen Gemmax, which is Gemma for translation. We have seen Silmakashif, which is a retrieval augmented generation for Arabic and English. But we have also seen people using Gemma to change the way they develop models, that they build models. So Lumina Image is a way in which they combine Gemma with few other models to do image generation. Or Omni Audio, which is a model that can also take audio as input. Or finally, Simpo, which is a different post-train technique. It's a different RLHF technique based on Gemma. So we're seeing people building research also on top of the open models that we release. It's been fantastic to see what the community built. Just a couple of months ago, we did a Kaggle competition focused on enabling the community to train Gemma for their own languages. And we saw thousands of people participating, contributing, sharing knowledge, collaborating. So this was very exciting, and now I'm happy to hand it over again to Gus, who will talk a bit more about some of his favorite case studies. Thanks.
Thank you. Nice. You thought you didn't have me anymore, right? So let's talk about how people are leveraging Gemma even further, right? We've seen lots of variants that Omar just showed, but we have some very cool use cases. For example, we have our friends from AI Singapore. They built the Sea Lion model. And the idea is they want to create a Gemma version that was very good on Southeast Asian languages. There's a bunch of those. And Gemma was good. There are many models that tried to do that. Our model was good. But what they did is they fine-tuned a Gemma 2 model, a 9B, to be the best Southeast Asian language model, period. And that's the scores there you can see. and we've been working with them to make even further updates to that and enable a lot of people to have access in their own language to a large language model, right? Beyond that, we have our colleagues on Insight, and they build the first national Bulgarian LLM, let's say like that. And what they did is they fine-tuned also a Gemma 2 model, again, a model that was English only, to be the best Bulgarian LLM period. And it's offered to citizens in Bulgaria, so every citizen can use. It's used by the government. So this is exactly what we want. We want to enable people to bring this to their communities, to their citizens, which is very, very cool, and giving this power to everyone, making accessible to everyone. So we're very proud of these use cases. And in terms of variants, there's of course the community ones. We're absurdly happy with them, but we also keep pushing our own variants, right? Going to new fields. I don't know if you saw, last month, we announced Dolphin Gemma, which is our first large language model for dolphin communication. The idea is, of course, to create, with this model, we create like a shared vocabulary with dolphins, and then we can, at some point, start to understand how to talk to them, right? We're not there yet. I don't want to sell hype. That's not what I do. This model is helping researchers get there, right? And we are using decades of field research data to train models to get there. This is very cool. It's coming soon. We are going to open that for everyone to play. Maybe you do a version for whales or for dogs. I don't know. Up to you. So this is great. It's coming soon. We also released yesterday Med Gemma, which is a Gemma variant for the health industry. The idea here is Gemma is good on visual and all, but when you start to use vocabulary, medical vocabulary, or images from health-related field, of course, Gemma is not great on that. It wasn't trained to do that. That's what Med Gemma helps you address. They fine-tuned Gemma 3 to be great for medical use cases, both image and text. They did the 4B and a 27B. These are available on Hugging Face, Vertex, and we are bringing to even more surfaces. So this is a very good for you to start playing on health apps. And why does this matter? When we talk about health-related applications, this is a field where you cannot just, let me send your data to any cloud anywhere. Let me do that. You cannot do that. There's a lot of regulation. So running completely local on your computer, on your server, that's very important, and MedGemma enables that, right? Gemma enables that, MedGemma enables that. We also mentioned yesterday Sign Gemma, where we're expanding Gemma to sign language. So you'll be able to do a sign, this is not a real sign, but you'll be able to do sign language with the model. It will translate that to text. At first it will be American Sign Language and English, but we are working with the community to make this in as many sign languages as possible. This is coming soon, hopefully really, really soon. And this is also another field we're expanding with our variants to help, again, engage the community, reach more people, help more people benefit from this kind of tools, right? And another variant that I'm very proud of is Shield Gemma. Shield Gemma, there's 1 and 2. Shield Gemma 2 specifically was released in March. It's a model as a safety classifier, but Shield Gemma 2 is specialized, for image. So you give an image and a prompt, and it can classify the safety of that image based on your prompt. And it's based on the Gemma 3 4B, which is already very strong. And how would you use that? You would put on a system that you have like a image input or text, and then you put Shield Gemma to, you could use that to protect your LLM that's after. You could put Shield Gemma after your model generates an image, for example, or and this is how you do how the safety classifier was built, right? You have a policy, images, and you train it. So Shield Gemma works in many, many places, helping your system become more responsible, safe, and all like that. And this is all great and all, but what I really want to know is what you are going to build next. Please reach out to us. We are all on social, or we will be there on the Q&A after this. I would love to understand how you're using Gemma, how you want to use Gemma, if Gemma can help you in your business. We've been talking to the community. We know how important it is, right? Well, a lot of people know me from talking to the community because I really think that we have to work all together, right? Your opinion is absurdly important. So thank you very much. We'll be at the AI Q&A. Omar and I will be there to, to answer all your questions. And thank you very much again. Have fun. Enjoy.